slowly started. So we're moving on to a new framework. We're gonna leave UIKit in the past, sort of, and move on to SwiftUI. So remember, this is our current agenda so far. Um, Remember last lecture we went through persistence and SnapKit. Remember that persistence is for both SwiftUI and UIKit. It's not like a framework specific thing. And remember, we use user defaults to store things in like a dictionary key value pair sort of situation. Remember that values that you store can only be primitive types, I believe, yeah. And SnapKit, remember, is UIKit specific. So if you do end up choosing SwiftUI for your hack challenge and A4, A4 is gonna have a SwiftUI version as well, so you can test your knowledge on SwiftUI. Then you can kind of forget SnapKit, but if you prefer UIKit, if you prefer writing more code, then you can revisit that. Nope. Yeah, and just a side note, a little, just announcements real quick. Today is the drop deadline, so if you feel like you're considering dropping or something, today's your last chance. And also, we're gonna have a guest lecture for the 12th lecture, and it's gonna be Jiwon. He's a really cool guy. He's very cracked, and he's gonna be teaching everyone here, including me and Jay, about Core ML. So it's very exciting stuff.
All right, let's get into SwiftUI. So what is SwiftUI? It is a declarative framework developed by Apple to build user interface. It's introduced in 2019 to replace UIKit. And basically, the code you write will be concise, readable, and it's going to be easier to maintain and extend upon. And SwiftUI is the future. So most likely, if you're writing an app, you will be writing in a SwiftUI. Unless you're maintaining an app like Eatery or Transit, we call it Navi nowadays. The code base is in UIKit. Otherwise, it probably using SwiftUI.
Yes.
Can you guys see this picture nicely? It's kind of small. So what's cool about SwiftUI is like after you write the code, there you can preview the code on the right side on the canvas, and it's very nice so that you don't have to build and run the project every time you do some update. You can just view it, change in real time. So it'll increase the speed of your development process.
A lot.
Yeah. So let's talk about the difference between declarative and imperative. So UIKit is an imperative. It tells the computer how to do something step by step. Like remember when we were doing UI collection view, we have to create a class that inherits from UI collection view cell, make it init function, create your views, and then do the helper function and all that. But SwiftUI is sweet. You just tell the computer what you want done, and then you don't have to worry about the underlying steps. So as you can see, the code in the bottom, this VStack is like, you can think of it kind of like as a table view. It just it makes us it makes like a vertical stack where you can just slam the components on there. Like this one, it slams the image, like the Apple globe image on there, and then right under it, it has a hello world. So it's literally like just vertical stack with the image and the text. And of course, the beauty is you can do a lot of things with a lot of fewer lines of code, as well as seeing the changes in real time through preview. So let's do a demo with creating a SwiftUI project. Okay, I'm gonna open up terminal. I'm just gonna go into the project, the folder that I use for this course, see course demo, and then okay, open up the folder. Oh, actually, I don't even need to. This is a habit, guys. We didn't have to go through terminal, but just click on Xcode and then press create a new project, and then choose app, project name, Swift UI demo. Team, don't worry about a team. Just use none or something like that. Organization and identifier. This is like to help you know your route of app. Doesn't really matter, and we're not gonna have a test suite for this. And I think it's default in SwiftUI nowadays, no? Okay, course demo, create. Yeah.
Oh, yeah, that's neat.
Yeah, so now like with the new Xcode, they don't even give you an option to do an UI kit with SwiftUI. It's just SwiftUI, so definitely.
Really?
Yeah, I didn't see an option for SwiftUI for UI kit. So
I should change it to iPhone.
yeah. So this is where you select where you want to deploy on. You guys should have a little bit of experience with this. With every assignment that you do, you kind of choose a simulator. So usually we use iPhone. Same here with preview. This is the preview we're talking about. So so the project navigator, you have a sample app that's Swift. It contains the code that is executed at launch, and then it's going to be kept alive throughout the app's lifetime. And then we also have a content view that's Swift. It contains the code that defines the UI for our app. And most of your code will be written similar like this, right? So SwiftUI demo app, it calls the content view when the app is being launched, and then the content view will contain some kind of view structure that just that your app navigates to. So we also have this hashtag preview, and then hashtag preview bracket content view. This is what allows us to see this preview. So if we delete it, we don't have the preview anymore. And then what is sweet is that you can like, can I make this bigger? So if I just say hello class, it updates real time. So this will speed up your development progress by a lot. But one downside is this take a little bit of RAM. I got a whole new MacBook because of preview, and I end up deciding to not use preview anymore. But you can still use preview. It's still very helpful. We went through this. Okay, so you notice here, like, we don't import the UI kit anymore. We just import the SwiftUI. And note that we use struct instead of class. So previously in UI kit, we use class because you have to inherit some type of view from the UI kit, and it has you inherit all of the properties from the original view class. So that's very heavy. That's why we use struct here. In the beginning of the class, we covered that the difference between struct and class is that when you pass a struct, it doesn't pass a reference to an object. When you pass a struct, you just make a whole new struct, and then you pass it in as like a brand new thing. So you make a copy of it, right? So the reason that we want to use struct, because it's faster. We don't have to pass all the inherited properties from some kind of view. Like in this struct, if we were to call it in another view, all it's being passed are these stuff.
Reminder that struct is also more lightweight, so inherently it's just going to be faster than a class.
Yeah. Oh, just went through this.
Yeah.
Okay. So you notice that we use text, hello world, and image, app dev logo, and then like if you want to make a rectangle, you can just call rectangle. But in the UI kit, you have to make a property called UI label, and then you have to make a property called UI image. But here it's very simple. You just do like image, some image, and then some name. This system image is like, you use this when you want to use some kind of image that already come with your MacBook. Every Mac has some kind of image. So like, if we want to say heart, somehow it already has heart. Yeah, it's star that field, like that. Or like if you want to just use some image from your assets, we don't have anything.
You can just drag it.
Yeah, I don't have any image to drag.
Just do it later.
Yeah, we can show you later. All right. let's bring it back to system image.
It's gonna be
System-
very similar to how you use UI image.
Yeah. Alright. Okay. Alright, don't discuss with your partner. So this is what you typically do in the UI label, UI kit, but then we don't do this in SwiftUI. All we need to do is text hello world foreground color. So what this does is like you make a text, and then when you're making so this one on the left with the UI kit, you initialize a UI text label with all of these properties, with all of these things you pass into the initializer. But this, you actually just initialize the text, and every modifier that you add on to it, you create a new one. But it's happening very fast, so people who are using your app won't notice that it's iteratively making the change. So we use the modifiers instead. So same with the image, we'll modify the image to, like if we want to allow the image to be resized to some kind of frame that you want to constrain to, you will use resizable and then scale to fit, stuff like that. We'll show you all of this in a minute. Do you want to talk about this?
Oh. Yeah, I mean he kind of went over it already, but remember each modifier is creating a new struct, basically it's returning a new struct, and then you can chain that with multiple modifiers, but since they're lightweight, they're really fast, really efficient. Wait, and like properties you just pass in when it's being initialized. So actually like when you create a class or when you create like a UI label, you just make it once, right? Instead of multiple times. So
yeah.
Right.
Okay, let's take a look at these modifiers. So for our text, we don't have any modifier right now, right? Now let's change the let's get rid of the image for now so we can lock in on the text. We can focus on the text. So we want to change the foreground color. So it's very nice, it already has it. Oh, apparently this will be deprecated, so in the future don't use foreground color, but you can still use this for now.
Oh, foreground style.
Oh, yeah. You have to, apparently, yeah. And then you just use a color like dot red, and it's changed to red. And then you want to change, we want to change the font. We just do font and then dot title, and it will change. Right, this preview is very nice. It's like you don't have to run it. And then we want to make the background dot blue, so the background is blue. And then like padding. Okay, like you don't see anything happening over here with padding because we're making a padding outside of like with this label. So if we add another component, it's not gonna be tied like right under the word. So yeah, so for example, if we make another text hello to, you see this spacing? So this is what the padding does, right? So that's how modifier works. You just dot something, so every time it makes a new new update to your text, right? Yeah, that's the next one. Yeah, and then it's important to know that the order does matter. So for example, this padding, because we put it at the end, it's applied to everything in the front. So, but then if we were to apply the padding before the background color, it will actually be like this, because the padding gets applied first, and then and then we apply the color on the padded text. So this is what ordering does when you use padding. It's especially important. Like I remember when I was doing the assignment 4 or the hack challenge, I spent a lot of time trying to figure out like how to make my app align to the design, because I wasn't really familiar with applying these padding. So remember that when you applying the padding before the background color will be applied to the whole padded text. But if you do it after, you're applying the padding to the whole text that is already applied with background.
Any questions? That makes sense.
Yeah.
Okay.
And Aston's gonna go over these view.
Oh, this. So you're gonna notice in the code. Oh wait, is it four? Oh, four fingers. Okay. That you have a return type of some view. So like, what does this actually mean? So your return type can be very complex, but we know it's gonna be some view, right? That conforms to view at the highest level. So what this is basically saying is we expect that we're gonna return like the highest level of view. That makes sense. So if you have a view, under view is like text. Text is a type of view, image is a type of view, and like a combination of that in like a V stack is also a view. So that's all this is saying here. Yeah. So it's just like another level of abstraction that helps, with flexibility. So that's what SwiftUI is all about. Yeah. Oh, so layouts. So yeah, another thing we're gonna go over is layouts. So previously, you remember we used tables and cells, UI collection on cells and all that, and it gets like there's a lot of boilerplate code. You have to conform to like the delegate, the data source, and all that. But what's cool with SwiftUI is we can use layout and use stacks instead. So VStack is essentially basically like a table view. But if you were to try to do this using a UI table view, you can imagine it's gonna be pretty hard compared to like here where you're just writing. I can't count right now, but probably under 10 lines of code. So yeah. Here HStack is a view that arranges its view in a horizontal line. So here HStack, we see text Cornell, text AppDev. So it's going through it like ordinally and placing Cornell in the first position of like this horizontal line, and then AppDev after that. So another example here is we literally just changed this V to an H, and lo and behold, it relayouts itself, decomposes. So that's pretty neat. And of course, we went through VStack. It's the same thing, but just vertical. Then another interesting thing is a Z stack. So this may be a little more confusing, but think of it like you have X, Y, and then you have Z. So like your X is the horizontal H stack, Y is your vertical V stack, and Z is gonna be like front to back. So like ordinally, this is gonna be in the very back, and then this is gonna be the second most back, but since it's the last one, it's gonna be the most forward. And imagine like there's another text thing here.
We can do that.
That would be in the middle. So yeah, I guess he'll demo it. VStack. So just as we expect, this text hello, it's kind of hard to see, but this hello 2 is in front of hello class. So yeah, that's VStack. It's very flexible, very easy. It's actually for the hack challenge, I would really recommend you learn SwiftUI and use it, since it's just so much faster to develop from the ground up. And then you have Spacer. Spacer is another thing. Well, just like its name hints, it's just a spacer. Kind of think of it like an empty view, where you can configure like how big it is by giving it like a constant. So let's see if we can do it here.
Spacer for ZStack.
Oh wait, oops. So let's do HStack. So yeah, it spaces it out. Tries to cover up as much space as possible. And then I think you can do, what was it? This, right? If you do 10. So you can play with the frame to sort of determine how far apart you want it. But the default is, I'm pretty sure, is trying to take up as much space as possible. And then let's confirm that with a VStack as well. So yeah, you see this is all the way at the top. Presumably this is the safe area layout guide, and then here all the way at the bottom. So boom. Okay, and there's also a ton more, but you're mostly probably gonna use like HStack, VStack, ZStack, and then lazy HStack, lazy VStack. It's probably the most used, top 5 most used, I guess. Also scroll view, and as you can guess, you make a view scrollable, and then yeah, divider, form, and etc. There's a lot more like tools you can use to lay out your views. So.
Yeah, like lazy VStack is like, remember in the collection view we had that mechanism like reuse with identifier to kind of, we only load the data that you see on the screen. So this is what lazy stacks do. So same in SwiftUI, we don't want to load all of your data at once that the user is not looking at it. So we use lazy VStack and lazy HStack to only load the data that are being present in the current screen.
So actually, to kind of follow up with that, HStack, VStack, and HStack, VStack normally does not have this like dequeuing caching mechanism. So anyone want to maybe come up with a case where it might be better to use the normal one versus the lazy one? I'll give you a hint. It's based on like the thing you're kind of iterating over. So actually, I'll just tell you. It'll be better with like a static amount of items. So let's say you have like 5 different filters, then probably using lazy doesn't make sense because you know you're gonna have 5. Whereas if you're like loading a list and you don't know, like there might be a lot of things in the list, then lazy would make more sense. So also lazy has more overhead, so it's gonna be more slow and complicated. Yeah.
All right. Right now we're gonna like make a pretty nice little app. We're gonna play with birds again. Right.
Always birds.
Yeah, we love birds. We have like everybody on the team gets like a bird design on iOS. Actually, we have a member who's like just draws bird.
She's graduating soon though, so someone's gonna have to like pick up the torch. It's who? Isn't it newbie draw? I forgot who.
Wait.
Actually, never mind. We can talk about it later.
All right. Okay. All right. Okay, same thing. Go to course email or course website, and then SwiftUI lecture. Clone the repository. I'm already in the directory that I use, so I just clone it, and then cd lecture 10, and open. So okay. All right. So notice how like we already have model. I think this is the same model as the collection view demo. And then we have a birdwatch app. This is the entrance of the app. So when we launch the app, it'll call content view. You can think of this like a root view. And then, okay.
iPad.
Yeah, I think. Yeah.
Is it always iPad?
Yeah, it defaults to iPad for me, so for some reason. All right. So let's erase all of this. This is the skeleton code that they gave us for free. I'll make an HStack.
Capitalize S.
Yeah. Is there somewhere that we can pull up an image so people can see, like, how it's supposed to look like at the end?
Wait, there should be images and assets.
No, like a complete version. It's okay. We just code it out. So we'll make a text. And this is 7.
another thing we kind of didn't go over is alignment. So there are different alignment modes that dictate like how things inside this, say this V stack is ordered, or sorry, laid out. I think next lecture we can go more in depth into it. So you see leading makes the text the leading, so like it starts, the exposition starts at the left.
Okay, so we kind of have everything here. Oh, this is lowercase. So we kind of have everything here. Let's format it, right? But right here we have a H stack. So this whole thing is horizontal, and then inside the H stack we started with the text 7, and then right next to it we have a V stack. So this V stack is inside this H stack, as you can see here. And then inside this V stack, on top we have the name of the person, and then the address, the location of the person. So Vincent, Texas, and then we have a spacer in between. It's like invisible here, and then we have an image. Now let's make this look a little prettier. That bold, and then we want to use padding to move this away from the V stack. So we notice how we use that trailing. So this padding only applied to the right side of this of the text.
Leading is left.
And then change the font weight for Vin. Texas. We don't want this. We don't. True is nice here, but we don't need it. Yeah. Okay.
So notice here the font applies to all the text inside. So that's a new way of reducing redundancy. But you have to be careful with like if you want like one text in there to have a different font, then you have to do a little messing around, tweaking.
Yeah. So notice how like this image is really big, and earlier we mentioned about resizable. So this allows us to get constrained to this. Well,
Yeah,
allows it to be
scales too.
resized. Yeah. It also scales. It doesn't just constrain. Sorry guys. Like, okay, and then we set the width 100, and then height set as 100. Okay.
Nice.
Okay.
So this is kind of looking like a row.
Yeah.
This is cool.
Let's move this over a little bit. All right.
That's good.
Okay. And then yeah, we can move on. So now we just hard coded one row of this table view looking like structure as like relative to the UI kit. Notice how for SwiftUI this is all the code that we need to write. It's very simple. But we don't want to hard code everything, so we can use this model. We actually hard coded this data, but we want to iterate through all of these birds and display all of them. So we're gonna now make a list to show all of these. Yeah. Let's make a function called private function func bird info row, and then bird sum view, and then now we can just pull all of this to here, and then we can delete this and just call it bird info row. All right. Wait.
Oh, sorry.
Yeah. List So for every bird, we're gonna call this bird info row.
So while he does that, I'll quickly comment on the ID thing. It might look weird, but it's actually necessary for this to like work efficiently. So what ID does basically is for each like bird, or I guess like inside the list, you have multiple of like the same kind of view. But when SwiftUI is creating this sort of like list, for each row, it needs to have an identifier, so that when it detects a change, like hey, in row 2, data changed, then instead of like having to refresh the entire like list, it'll just like know just to change that. So yeah, it's a smart way of just making things more efficient.
Yeah.
Yeah.
So
yeah.
yeah.
Go ahead.
Notice how this error here, that's because we didn't conform the struct to hashable. This will allow us to iterate through this model. So now it should work. Let's solve in, because we hard coded here. So we want to just use the properties in the model. So bird.count. Notice how this will not work, because this text is expecting a string, but this is an integer. So we want to do this. Perfect. Now it has all the number. Same for here. We can do bird.name, and then for the location, bird.location, and then for image, we just do bird.image. Oops. Yeah. What? Yeah. Because like this is all the properties that we have, and we use all of them here.
And notice image is a string that corresponds to like the name and assets.
Yep.
So it's very similar to how we did it in the UI collection view.
Okay. So nice.
A lot simpler, a lot cleaner code. I like it a lot better than UI Kit.
Yeah. Okay. So right here we did everything in content view, but in SwiftUI, you can easily make another file and just call that file to put it in this view, to put it in this file. So yeah, we can make a file called birdlist_view. Okay, and then we want to import SwiftUI. See, it's already giving us the code. You make a struct called birdlist_view, and then it's a type of view, var body some view. You almost always have to have this when you make a new view. And then now we can just move everything. You know what? We can just move everything from top to bottom into birdlist_view. And then in the content view, we can just call it birdlist_view.
Oh, the var body.
Oh, right. Sorry. There's a var. See, I just talked about this. I forgot. Birdlist_view. Yep.
Does that make sense? Any questions about anything? Not yet. That was the demo. Thank you guys for tuning in. Also, another note on Hashable. Remember, I talked about the ID thing. Hashable allows it to be ID'd by definition of what Hashable means. So, yeah, whenever like you're iterating through lists and stuff, having Hashable is nice. So, yeah, that's it.
All right.
Yeah, we'll move on to the Kahoot. and then we're done for the day.